I know it's a little bit crude with the masking tape holding everything on, but I just wanted to test this and see what kind of amplification factor we were actually getting with the toroid. Okay, we're pulling just a little bit more than 1 amp, and we are running at 920 RPM. Working right here with just the positive and the negative. These two leads are going up to the meter, and we're pushing the cap up right now. It's 287 volts on that cap there. And the only thing I've done is put a diode in line on the negative so the positive doesn't feed back and negate what we're trying to do here. I'm using my best wire here. You can see it's silver. It's 16 gauge copper. It's silver plated, and then the insulation is Teflon. It's about as good as it gets. I figured that if we're going to work with radiant, that I might as well use the best of the wire to make these contacts and use that skin effect. So there we are with just 3 wires actually. This is our old negative wire. That's our old negative wire coming in right there, and that's actually a positive, I believe. Yeah, it's going to the positive, and it's right next to the negative. Interesting. And then the other negative is at 90 degrees, and it's riding on a copper band that I put all the way around the hub to get a little bit better contact than the copper. And so yeah, that works. Yeah, it's still climbing up. It's pretty interesting. Take the capacitor off over here, and it'll be about, well, let's go ahead and do it. Boy, I don't want to touch those. That's a heck of a spark. So we're running at 72, okay, 72, 71, 63. So you see the voltage jumps around, but if you take off these wires and this wire for the amplification, it drops down to about 8 volts. Okay, I said 8 volts without the wires. I think I'm mistaken here, so let's just check it. We're still jumping up between 65 and 75 volts. Standing voltage output without the capacitor connected. So let's see if I can pull these wires away with some kind of I don't know if I can do this and show you. That's pretty close. Okay, it's 11 volts. So it's not 8, it's 11 volts because we are running a higher RPM at 920. So 11 volts and 75. So we're talking about a 600% amplification factor in output power. It's not too bad. Okay, I shut the machine off and let it stop so that you could see this copper band in here and see where the set screw holes are on the hub. You can see them 180 degrees apart. So now with this arrangement with the copper, it gets a much better contact. And I know it's a goofy kind of arrangement, but for now I'm just testing different aspects of it just to see, you know, what kind of results we can get. But so far I'm really happy. It's working out really good, and it's going to make an absolutely incredible addition to the rest of this stuff in here that's already very useful. So there we are. Okay, I've dropped it back down to the 360 milliamps that we did the last test with, and we are running again, sorry, at 639 RPM this time with 360 milliamps of current draw. And back with the crude arrangement here again. Please don't think that I'm going to remain with this. This is just for testing, and it's got tons and tons of friction, and we don't want that for sure. Right now, it's at that slow speed. It's been jumping up between 55 and 65 volts as far as the output. There's nothing connected to anything, just going to the voltmeter so that we can see what's going on. But I want you to see again, when I remove the power, it drops down to 7.4 volts. So to 7.4 volts to roughly 60. So even at the slower RPM, we're still amplifying at about 600% increase. Thought you might like to see that too. One final note in closing, and perhaps you already know this, but when this thing's operating, nothing ever gets hot anywhere. Not these coils, not these wires, not this hub, not this copper, not the bridge rectifier, not even that tiny little diode, not these wires, nothing. Nothing gets hot. It stays room temperature, if anything. It doesn't even warm up, so it's pretty amazing. And again, with the skin effect of this silver wire here, it's solid gauge copper, plated with silver, covered in Teflon. It transfers that those radiant bursts very, very well down to the bridge rectifier and then out. And this, we are not shorting these coils. That's not the idea of this. We're shorting the DC that's coming out of the bridge rectifier. That's what's doing this, just like Tesla did. Thanks.